One of the most fascinating planets in our solar system is Venus, often referred to as Earth's twin. This is because Venus shares many similarities with Earth in terms of size, mass, and structural features. But today, when we look at Venus, we see unbearable temperatures, toxic clouds, and crushing atmospheric pressure. So how did Venus, which started out with such similarities to Earth, transform into such an uninhabitable hellscape? In the early days of the solar system, Venus and Earth were remarkably alike. Both planets formed from the same disk of gas and dust surrounding the young sun, which led to their similar size, mass, and composition. Scientists believe that billions of years ago, Venus may have had conditions that weren't too different from Earth's. It's possible that Venus had liquid water, temperate climates, and maybe even the right ingredients for life. Venus orbits slightly closer to the Sun than Earth, but for a long time, this wasn't seen as a major issue. In fact, early astronomers speculated that Venus could be home to lush, tropical forests or vast oceans. The planet's thick cloud cover prevented clear observations, fueling the mystery and hope that Venus might be a second Earth, hidden beneath those clouds. However, as we now know, despite their common origins, Venus and Earth took very different paths. While Earth developed a delicate balance that allowed life to thrive, Venus descended into a runaway greenhouse effect, transforming into the hostile world we see today. One of the key reasons for Venus' transformation into a hellish world is the runaway greenhouse effect. While both Earth and Venus have atmospheres that trap heat from the Sun, Venus's atmosphere is made up mostly of carbon dioxide, a powerful greenhouse gas. This thick CO2 blanket traps immense amounts of heat, preventing it from escaping back into space. As the surface of Venus heated up, any water that may have existed evaporated, further intensifying the greenhouse effect. Water vapor is itself a potent greenhouse gas, so as more water vapor entered the atmosphere, it trapped even more heat, creating a vicious cycle. This feedback loop caused Venus's surface temperatures to skyrocket to over 460 degrees Celsius, 860 degrees Fahrenheit, making it the hottest planet in our solar system, even hotter than Mercury, which is closer to the Sun. The runaway greenhouse effect didn't just heat up Venus, it also reshaped the planet's surface, making it a dry, barren landscape with no signs of water or life. What could have been a temperate, water-rich planet like Earth became an inhospitable furnace with an atmosphere so thick and oppressive that sunlight barely reaches the surface. One of the most striking features of Venus is its incredibly thick atmosphere, which contributes to both its intense heat and crushing pressure. The atmosphere is composed primarily of carbon dioxide, with clouds of sulfuric acid swirling above the surface. This dense layer of gas traps heat, but also creates an atmospheric pressure 92 times greater than what we experience on Earth. To put this in perspective, standing on the surface of Venus would feel like being almost a kilometer, 0.6 miles, underwater on Earth. The immense pressure would crush any human-made lander not designed for these extreme conditions, and it certainly makes Venus uninhabitable for any form of life as we know it. This thick, suffocating atmosphere is also what gives Venus its famously opaque appearance. The sulfuric acid clouds reflect much of the sunlight that hits the planet, making it one of the brightest objects in our sky. But beneath these clouds, the planet's surface remains shrouded in darkness, heated from within by the trapped heat and kept under constant immense pressure. The atmospheric conditions on Venus are so severe that any spacecraft attempting to land can only survive for a short time before being destroyed by the harsh environment. Water plays a crucial role in regulating climate on planets like Earth, where it helps absorb heat and maintain a balanced greenhouse effect. But on Venus, any liquid water that may have existed early in its history evaporated due to rising temperatures. As Venus heated up, its oceans, if they ever existed, boiled away, and the water vapor contributed to the planet's runaway greenhouse effect. Since water vapor is a powerful greenhouse gas, this only worsened the situation by trapping even more heat in the atmosphere. With no water left to absorb and moderate heat, Venus's surface became bone dry. The loss of water also meant that Venus could not form the same climate-regulating cycles that Earth has, such as the carbon silicate cycle, which helps remove carbon dioxide from the atmosphere. This absence of water was a major turning point in Venus' transition from a possibly habitable planet to a fiery wasteland. Venus is about 70% closer to the Sun than Earth, and this proximity had a significant impact on its fate. Although the distance between Earth and Venus may not seem that large, it made a critical difference in how much solar energy the planet received. Being closer to the Sun, Venus was subjected to more intense solar radiation, which contributed to its higher temperatures early on. This additional solar energy likely caused Venus to warm up much faster than Earth, speeding up the evaporation of its water and accelerating the greenhouse effect. While Earth managed to stay cool enough to sustain liquid water and a stable climate, Venus's closer orbit put it on a path of runaway heating. This closer proximity to the Sun is one of the key reasons why Venus couldn't maintain a balanced climate like Earth did. Another critical factor in Venus's downfall is the absence of a significant magnetic field. On Earth, our magnetic field acts as a shield, protecting our atmosphere from the Sun's solar winds, streams of charged particles that can strip away atmospheric gases over time. Without this protection, Venus was left vulnerable. Venus likely had a much thicker atmosphere in the past, but without a magnetic field to defend it, solar winds gradually eroded it away. What was left behind was a dense carbon dioxide-rich atmosphere that only trapped more heat. The lack of a magnetic field also meant that Venus couldn't maintain the same atmospheric stability that Earth enjoys, further contributing to its transformation into a hostile environment. Venus's story serves as a powerful warning about the potential consequences of uncontrolled climate change. The runaway greenhouse effect that transformed Venus into a scorching, lifeless planet illustrates what can happen when greenhouse gases accumulate unchecked. On Earth, we see a much more moderate version of the greenhouse effect, which is essential for keeping our planet warm enough to support life. However, human activities, such as burning fossil fuels, are increasing the levels of greenhouse gases in our atmosphere, pushing the natural balance to its limits. Venus shows us that even small changes in atmospheric composition can have dramatic consequences over time. While Earth is nowhere near Venus's extreme conditions, the lesson is clear. A planet's climate can spiral out of control if delicate systems like the greenhouse effect are thrown off balance. The transformation of Venus from a potentially habitable world to an uninhabitable hellscape reminds us that we must carefully manage our own planet's atmosphere to avoid a similar fate.